Hi everyone, it's Miss Wong here. We're going to be going over graph number 2 that was in practice worksheet number 2. Alrighty, so we have a graph here, that's great. And we're going to label each segment, each different type of motion that we see on this graph. So A, B, C, D, E. They all have different types of motions, distinguishable from every separate straight line that we see. So let's answer question number 1. Tell a point form story of that motion that occurs in each segment. You can write it right on the segment line or in these lines down here. So I'm going to write a story. You are climbing down. So that's part A there. We're going down towards the x-axis. Therefore, it's going to be a negative velocity. You are climbing down a ladder, stopping. So that's the line or the motion for B there. We're stopping because we're at the same distance during this time, stopping occasionally, and then deciding to continue going down. So C, you're going down that ladder again, and you're moving again. So your velocity again is going towards the x-axis. We see that in that straight diagonal slope going towards the x-axis, that it's going down, okay? And then at part D, again, you are stopping. You're taking breaks. This must be a very long ladder. So we're stopping. So that's D. Again, just to catch up some air, you're at a very high altitude and now you're going down. You gotta take your breaths in slowly. And now at part E, we decide that we're gonna climb back up. We prefer higher altitudes. So climb back up ladder at section E there. So all the points that we're now going to work on question 2 here, all the points, you have to label which sections are stopped or moving toward that motion detector. When I say motion detector, I just mean moving towards the x-axis and moving away from the x-axis. So the stop points, we see the flat horizontal lines, meaning that it is zero velocity, and it's stopped at B and D. Moving toward the motion detector, we see that A is moving towards the x-axis. C is moving towards the x-axis, so it's A and C. Moving away from the motion detector, moving away from the x-axis is E. Therefore, it should have a positive velocity, whereas the slopes moving towards the x-axis will have a negative velocity. So let's calculate the value of the velocity between 0 and 2 seconds. So we're calculating for this segment or phase of movement, A. And we're going to choose points. So this was 2 seconds, which is our TF. 0 is our TI. This point here, I'm going to say it's 1.5, and that's our DF. And then at 3 is our DI. All right, so let's enter into that slope formula that we saw before. V, putting an arrow because it is a vector. Velocity has magnitude and direction. Change in displacement, change in time. dF minus di over TF minus Ti. You get 1.5 minus 3 meters. This is meters. Practice putting those units. And then 2 seconds minus 0 seconds, you get a negative 1.5 meters over 2 seconds. And therefore, your final answer is negative 0.75 meters per second. All right. Does that make sense? Yes, because A is moving towards the x-axis. Therefore, that slope, okay, it's a constant velocity because any point that you use to enter into the formula will get you negative 0.75. It's negative because it's moving towards the x-axis. It's going to be a negative velocity. and it is constant, so any point will be 0.75 meters per second. So that makes sense for A. Let's calculate the value of velocity between 2 seconds and 4 seconds now. So that's around here. Right around here. So 2 seconds to 4 seconds. Now 2 is going to become our TI, 4 seconds is going to become our TF, and then right here we're going to choose those definite points because this is a horizontal straight line, so zero velocity. It's still a uniform non-movement. Therefore, if you choose any of these points here and plug it into that slope formula, you're going to get the same velocity. This is DF and DI. We're going to plug those points into our formula. V, D, okay. We're going to plug in DF of 1.5 meters minus 1.5 meters. Our time is 4 seconds minus 2 seconds. 1.5 minus 1.5, you get 0 meters. And then 4 seconds minus 2 seconds, you get 2 seconds. Anything divided by 0, you'll get 0. And our units will be meters per second. So our velocity is 0, which we estimated because of that flat line. Okay, that flat horizontal line means 0 velocity. Okay, let's move on to the next one. Calculate the value of the velocity between 7 seconds and 10 seconds. Well, 7 seconds is about here. And 10 seconds is, 7 seconds is about here, and 10 seconds is right here. So we're calculating the slope for E. So if we choose any of these points here, we're going to get the same number for velocity because that straight diagonal line that's moving away from the x-axis is constant. Uniform motion, therefore any points that we choose will give us the same number for velocity. So we're going to choose points that are easier to identify. So we're going to choose points at 0.5 here, and we're going to also choose points at 3 because we see it directly on the graph. We don't have to work and guess with decimal numbers here. So let's plug those numbers into our formula. Oops, there we go. All right, so plugging that into our formula, we get 3 meters minus 0.5 meters. And 10 seconds minus 7 seconds, you get 2.5 meters divided by 3 seconds, and a velocity of 0.83 meters per second. Notice how this velocity is a plus value, okay? So it's positive. And notice how this velocity, 8.3, is larger than 0.75 if you're ignoring the signs. And if you're looking back at the steepness of E compared to A, E is more steeper, therefore that larger number makes sense. And also the positive 0.83 value makes sense because this line is moving away from the x-axis, therefore our velocity should be positive. Let's answer this next question. Calculate the value of the average velocity between 2 seconds and 7 seconds. So let's look at our graph here. Let's erase some of these random things I wrote on the graph so we can clear it up here. And we're going to look for here to, what was the question, till 7 seconds. So around here. So we are going to calculate what is the average velocity when you put 0 velocity and a slope and a 0 velocity. So let's calculate for that. We're going to choose definite points. So we know this is 7 seconds, so that will be our TF. This is our TI, and our DF is right here of 0.5, and our DI here of 1.5. So let's plug that in. VI. Okay, so DF we said was 0.5 minus 1.5 meters. Practice putting in those units. And then we have 7 seconds minus 2 seconds. We get negative 1.0 over 5 seconds. And this is meters. And then your average answer is negative 2.0, negative negative 0.2 meters per second. All right, so it's negative because of this portion here, okay? It's going down towards the x-axis. It makes the entire thing negative once we average it, okay? And we notice that 0.2 is much smaller than 0.8 and 0.75 because we're averaging this velocity with horizontal velocities, which means 0. So we're going 0, average with 0, average with that little portion, that slope, okay? That's why you get such a smaller number, which makes sense. Determine the distance and the total displacement from 0 seconds to 10 seconds. So we want the distance for the entire thing and the displacement for the entire thing. So how do we solve that? D, you check out your positions and your movements, okay? So D here, we have a movement. We're going to add each section up here. So this right here, this movement here is 1 meter. Add another half meter here, 0.5 meters. Equals 1.5 meters. And then here, this is constant and it's staying at the same position, so we don't include that. But here is another full meter. We'll add those up. Equals 2.5 meters. Here is 1 meter. Another block here, 1 meter. Another half meter here will give us another 2.5 meters. Therefore, it's 2.5 meters plus 2.5 meters will give us a total distance of 5 meters that this object moved. Its motion was a total of 5 meters. Now let's solve for the displacement. So we're just going to erase all this here so we have a clean state. Okay, so our displacement, putting an arrow on top to show it's a vector, that it is displacement. Look at and compare our initial with our final positions. Our initial position was at 3 meters. Our final position was at 3 meters. So the overall change in position is the exact same. So we have 0 meters. The direction is not needed because it's 0. If it was down here instead, then our change in position, okay, change in position would be a minus 1 meter from our original, okay, and that would be west, 1 meter west of our original position. But however, it's not, therefore it's just 0 meters, and that's how you solve for distance and displacement. All right, I hope you guys have a wonderful day.